Thank you, sir.
We'll wait 1 or 2 minutes, sir.
Okay, sir.
Kishore sir.
Sir.
Yeah, begin the session, sir.
Okay, sir. Good evening, everybody. I welcome all the participants to KSRM faculty lecture series. Today's resource person is from EEE department, Sri K. Kalyan Kumar sir. I invite Kalyan Kumar sir and I request him to start the session, sir.
Okay, thank you, sir. Good evening, all. Myself, Kalyan Kumar, Assistant Professor from EEE department. Today, I am going to present interpolation and curve fitting techniques using MATLAB. Interpolation and curve fitting techniques. So first, let us see interpolation. What is meant by interpolation? Suppose in our labs, we are going to conduct experiment, and from that experiment, we will get the data of two sets. Suppose let us assume. And one set I am taking in x value, x variable, and other set I am taking on variable y. Now, this data we are going to get at certain values only. Suppose I am taking current and voltages values. For current values I am taking in x variable and voltage values I am taking in y variable. 1 for current of 1 amperes, what is the voltage? For 2, 3, 4, 5. This is the practical data that we have obtained. Now, by using this data, I can plot a graph between the x values and y values, that is current and voltages. Suppose this is 3, 7, 11, 15, 25 like that. Then I can take the current values on one axis and voltage values on another axis, and I can plot the graph between the x values and y values. Suppose if current is taken along the x-axis and voltage is taken along the y-axis, then the graph, if I got like this, suppose this is the known value from the data and this is another known value. Now, from these two known values, two known points, if you want to estimate any value other than this measured value, suppose this is at 1 and this is at 2. If I want to know the value of y at 1.5, for I equal to 1.5, what is the value of voltage that I want to find out? So this estimation of data is called as interpolation. So interpolation is nothing but estimation of the data points between two known points. And the most common interpolation technique that we are going to use is linear interpolation. Linear interpolation means the data is going to be estimated by using a linear equation y equal to mx plus c. This is the standard equation that we are going to get in geometry. So y equal to mx plus c. So linear equation. By using this linear equation, we are going to estimate. And in MATLAB, in order to estimate the data using one-dimensional interpolation, we are going to use the function interpolation 1 as the MATLAB function, interpolation 1. So this 1 stands for one-dimensional interpolation. INTERP, interpolation short form, INTERP1 of is going to be the function that we are going to use for one-dimensional interpolation. And the default type of interpolation that we are going to perform is linear interpolation. So in this, the unknown quantity is going to be measured by using a linear equation. But in addition to this linear interpolation, there are some other types are available in MATLAB. Those are cubic interpolation, spline interpolation, nearest interpolation. If you want to know what the data that we have to give as the input and what is the output that we are going to get and how it's going to compute, then we can use the command help interpolation 1 in the command window. So in command window, there will be a cursor symbol like this. So after this prompt signal, if you type help interpolation 1, then you will get the entire information regarding the interpolation 1, how to use that interpolation 1 and what is the inputs that we had to give, that everything can be known to us by using this help function. So to understand the interpolation in a better manner, let's take one example. So here I am taking two sets of data. So one set I am taking as X, other set I am taking as Y. The X values are chosen as -7, -5, -3, -1, 1, 3, 5, 7. And Y values are 49, 25, 9, 1, 1, 9, 25, 49. If you see this data, we had measured the quantities after every +2 value. So the X value is incremented by +2 every time. So corresponding Y values we have measured. Now, if you want to know the values in between these measured quantities, so in between -7 and -5, or -5 and -3, or -3 and -1, so like that, any between two sets of data, if you want to measure the Y value corresponding to this X value, then we can use the interpolation technique. First, let's plot the X data and Y data using MATLAB. So the X data, I use the command -7 :2 :7. So here the colon notation is used to represent this data. So this colon notation represents, this is the first number, -7 :2 :7. This -7 stands for first number and 7 is the last number. So from first to last, with the increment of 2, I am going to take the X values. So X values are having a common difference. So all are displaced by +2 value. So I am writing this data, instead of writing all the values, I use a array creation with column notation. So X equal to -7 :2 :7 will create the data set -72 +7 as given in the X. Next, the Y values I have taken as it is. And if I want to plot, then I can use the function plot X comma Y comma within single quotations dash or O. Here, this dash indicates solid line. So the graph should be plotted with a solid line, and R indicates the graph should be in red color, and this O indicates the pointers. So what are the points that we are having? -7, 45, -5, 25, -3, 9, all should be represented using the marker O. So O is the marker, and grid. So the grid lines that I have used. So if you run this command, then we are going to get the graph as shown in this figure. Okay. Now our problem is here I don't know the value of Y for the given value of X. Now the problem I have defined as, if you want to find the interpolated value for X equal to 4, if you want to find out the interpolated value of Y for X equal to 4, then how to obtain? Now let's see the MATLAB example to plot this graph. So this is the data that I have already copied. Now if I run this, I will get a graph like this. And if you observe the data that I have taken in the example, the values of y are such that y equal to x square. This is of the form y equal to x square. So when x equal to 4, I have to get y equal to 6. For x equal to 4, I have to get y equal to 16. Y equal to 16, I should have to get. But if you see the graph that I have plotted here, if I zoom it, so before that, for better appearance, I am increasing the line width of the graph. So this is the graph that we have obtained. Now from this graph, if you zoom it for x equal to 4, we are going to get 17. For x equal to 4, I am getting 17. But the theoretical answer is for x equal to 4, y should be 16. But as the points are connected by using a straight line equation, function. Now, if you use this interpolated function for x equal to 4, that x new value I am taking as 4, for that x equal to 4, if you calculate the y value, that y value we are going to get as 17. The 17 value is same graph. So here graph corresponding to y x equal to 4, we are having 17. Therefore, similar to the graph, we are going to get the result as 17 for interpolation function. So the interpolation function will compute similar to that of linear joining of points. Now the other ways, if you see, so this is linear. So in the previous example, we have not given any extra input argument, interpolate x comma y comma new x value that we have taken, but here we have given extra input argument, linear. So it computes the line joinings of the 2 points taking as a linear function. Next, the alternative 2 are cubic and spline and linear. In the 3 cases, if you compute the answer, then the answer we are going to get as for cubic interpolation 15.9333, and spline interpolation we are going to get 16, and nearest interpolation we are going to get 25. So cubic interpolation, linear interpolation, cubic, linear, spline and nearest. So 4 interpolation techniques we have seen. For linear, the answer is 17, the same answer that we are going to get as a graphical solution. Cubic interpolation here and cubic and spline, the MATLAB is going to join the points by using a cubic quadratic equation, and then it's going to compute the y value corresponding to the new x value. And then in the nearest interpolation, among the measured data values that we know, among those 2, which is nearer to the asking required value, that value is going to compute. According to that value, it's going to give the answer. So here we are asking to measure for 4. So from the given data, we are having the value for 3 and 5, x equal to 3 and x equal to 5. So we are computing at x equal to 4. So for x equal to 4, 3 and 5 are the boundary points. So among these 2, the nearest point is going to compute in the ascending order. So it's going to take 5 as the nearest point. So corresponding to x equal to 5, y equal to 25. So the nearest interpolation will give the output as 25. Okay. So this is the difference between the 4 types of interpolation. So the first 2 results without any argument and linear interpolation as the input argument. in both cases, the MATLAB is going to compute the estimated value by using linear interpolation, same as in graph. Next, for cubic and spline interpolation, it is going to fit the curve using the cubic expression, that means third order equation, and then it's going to measure the estimated value. But in the two cases, it's going to take the constants as different values. Now, the cubic interpolation is going to maintain the data monotonicity, and whereas the spline interpolation will exhibit the greatest smoothness. So, spline will try to smoothen the curve as much as possible. Next, the crudest interpolation is the nearest integer. So, the estimated value is far different from the actual value. Now, how to choose the interpolation? So we are having four methods: linear interpolation, cubic interpolation, and spline interpolation, nearest interpolation. Which one we have to prefer for making the estimation of data? So in most of the cases, linear interpolation is sufficient, as it is the default method for plotting the graph. So it is sufficient for most of the problems. But the linear nearest neighborhood method is going to give a large error, so it is rarely used, but its speed is going to be very high. So it's going to be used whenever the data set is large. So I take only few points, but whenever the data set is going to consist of thousands of points, then in order to get the solution in a faster manner, we are going to use nearest neighborhood method. And the most time consuming method is spline method, but it's going to give the desirable results. So based upon our requirement, we can choose either linear interpolation or spline interpolation or nearest interpolation method. Next method is curve fitting. So in the previous discussion, we have seen that whenever we are having two sets of data, if you want to know the estimated value at a point which is not at a measurable point, so measure చేసిన పాయింట్స్ దగ్గర కాకుండా వేరే పాయింట్స్ దగ్గర డేటాను ఎస్టిమేట్ చేయాలంటే ఎలా చేస్తామని ఇంటర్పోలేషన్ టెక్నిక్ లో చేసాం. ఇప్పుడు కర్వ్ ఫిట్టింగ్ లో ఏం చేస్తున్నామంటే వీఆర్ గోయింగ్ టు డిరైవ్ a relationship between the y and x. That means we are going to write the y in terms of x as a function of x. So by using, we are going to develop the mathematical relationship between the y and x. So as we have the mathematical relationship, then for any given value of x, we can obtain the value of y. So when we are having a set of data points, then by using the data points, we are going to develop the relationship between the two data points. It is most helpful when we don't know any relation. In the previous example, from the x values and y values that we have taken as example, we can easily write y equal to x square. So by observing the values of y with respect to the x, we can easily come to know that y equal to x square. But sometimes it is not possible. When we are taking the practical experimental data, especially, it's not possible to get a mathematical relationship between the y values and x values. So in such cases, we can develop the relationship by using curve fitting technique. So the built-in curve fitting functions that exist in MATLAB are going to allow us to create an empirical data model between the y and x values. And the model, what are the model that the MATLAB is going to develop? That model is going to be works in a good manner within the region of collected data only. Suppose we are taking in the previous example -7 to +7. So whatever the mathematical relation between the y and x that MATLAB is going to develop, that will help, that will works in a good manner within the limits of -7 to +7. So when the limits are exceeding beyond this -7 to 7, the accuracy and the relation between the y and x is going to not that much good. And the functions available in the MATLAB for curve fitting is polyfit and polyvalue. And these techniques are going to develop a nth order quadratic polynomial using least square approximation. Okay. Now, if you choose n equal to 1 as the order of the polynomial, then we are going to get a straight line approximation y equal to ax plus b form. Or if you use n equal to 2, then we are going to get a quadratic polynomial a1x squared plus a2x plus a3. So quadratic equation we are going to get. So like that we are going to get. Suppose if n equal to 3, then we are going to get cubic polynomial a1x cube plus a2x squared plus a3x plus a4. Like that we can develop a nth order polynomial to best fit the data that we are having. So to understand this, let's consider example. Here randomly I have taken the values x and y. So x is varied between 0 to 1 with the increment of 0.1. For each x value, the y values are chosen by using the random function, and in order to get the relationship between y and x, if you want to get a linear relationship, that is y equal to ax plus b. So here order of x is 1, highest order of x is 1. Therefore, here for the polypit function, the input that we have to give is x values and y values and the order of equation 1. Then the output of this command is p equal to 10.3185, 1.44. So this will become x coefficient and this will become constant term. So y of x equal to 10.3185x plus 1.44. So the relationship between x and y we have developed as a linear regression formula. Now, if you want to get a quadratic equation, then we can use p equal to polyfit x values and y values and the order of equation as 2. Then we are going to get constant term x power 1 term, this is x power 0 constant term, this is x power 1 x coefficient, and this is x squared term. So the equation relationship between the y and x will become y of x equal to minus 9.8108 x squared plus 20.1293x minus 0.0317. So this is the relationship between y and x. Then to compare the curve fitting technique, let's plot the curves that we are going to obtain with this polynomial and this polynomial. So this is the basic equation. So x values, y values, automatically they will connect by using the linear relationship. So I am taking the same x and y as it is, and for plotting the curve between these x values and y values corresponding to this relation, so quadratic equation, I am taking the new x values xi as in between 0 to 1, I have taken 100 values, and the corresponding y values I am going to compute using the relation p. So that is, this is the p minus 9.818. This is the quadratic equation that I am having. With this quadratic equation, the new x values here, the line space. So line space stands for linear spacing. Linear spacing. So it's going to linearly space the values between 0 and 1, and the number of values it's going to place is 100 values. So between 0 to 1, 100 values will be linearly spaced. Using this function. Now for this 100 values, I am going to compute the y values by using the function polyvalue p comma xi. Now with the computed value of xi and yy, if you plot another graph. So here the first graph we are plotting as a solid line with O as the marker points. So this is the blue line. So here the solid line and markers are represented by using the circles. Now the second quadratic equation values xi to yi, we are having a dotted line. The markers are not represented as they are 100. It is becomes some inconvenient to represent those values. So I have not taken the marker values, marker representation here. So this dot dash represents the dash line for 0 to 1, between 0 to 1 by taking 100 values. So if you see The actual values are the marker values, and the marker values are joined through blue line, represents a linear interpolation. So the points are joined through linear equation, whereas this dash line is represented such that the points are joined by using a quadratic equation. Now, if you see, the smoothness of the curve has been improved, but the curve is not passing through all the points. So with the curve fitting, it is not necessary that the curve is not going to pass through all the points, but it's going to give approximate representation. So the smoothness of the curve is going to increase. There are some up and downs. So it's take an average representation. Now, we have seen first order n equal to 1, second order n equal to 2. So like that, you can go for n equal to 3, n equal to 4, like that, so on. So if you go on, use the points, the curve will come closer and it will become smoother. But when you go beyond certain limit, the curve will deviate from the existing points. So what is the limit? How to choose the order? So whether I have to represent the relationship using quadratic, that is second order equation or third order equation or fourth order equation, like that, what is the maximum order that we can choose? So let's see how to choose the value of polynomial. So the choice of polynomial is arbitrary. It takes 2 points to define a straight line. So straight line define cheyalante manaku at least 2 points undali. Suppose if you want to represent a quadratic equation, then we require 3 data points. So x values, y values. If you are having 2 points, then you can develop a quadratic equation, y equal to mx plus c. Next, if you are having 3 data points, then you can represent using the form ax square plus bx plus c. If you are having 4 points, then you can represent using cubic, that is third order. So like that, if you are having n plus 1 data points, then you can develop a nth order polynomial. So in the present example, if you are having 11 data points, 0 to 1, we are having 11 data points here. Therefore, the maximum order of the polynomial that we can develop for this x and y data is 10th order. So for our problem, if you develop a 10th order polynomial, so I am taking PP as the polynomial. So polyfit x comma y for 10th order, we will get 10th order equation, x power 10 plus x power 9 plus x power 8, so on, constant. So a1 x power 10, a2 x power 9, a3 x8, and so on, up to constant term. So this a1, a2, a3 values can be obtained by using this PP output of this function. Now, using this equation, this is y of x. So here, if you choose that same 100 points that I have used for xi, for that 100 points, if you compute the y values, and the y values are stored in y10, and if you plot the graph by taking xi on x-axis, y10 on y-axis, then if you compare all the 3 graphs, that is linear equation graph and quadratic equation graph and 10th order equation graph. So this red line, what I have used here, that red line represents linear equation graph. This is linear, and quadratic equation graph is represented by using the green. So this G stands for green curve. So this is second order equation. Second order quadratic equation, and this blue line indicates, this blue indicates 10th order. So if you observe, the second order is nearer to the actual measured points, but the 10th order is deviating by a large value. So we should not go for higher. So the third order equation or fourth order is sufficient. If it is possible to get the third order equation, if you are having 4 data set points, then you can go up to third order, or fourth order is sufficient. We should not go beyond that. Okay. So by using these techniques, we can develop the relationship that we do not have any relation. where we do not have any relation. Suppose for a practical experimental data, if you have two data sets, then between these two data sets, you can get the empirical relation y equal to f of x by using the polyfit. And the relationship, the order of the relationship, the polynomial that relates the y and x can be chosen by giving the third input argument. This gives the order of the polynomial, and the order can be a maximum based upon the number of data points. If there are n plus 1 data points, then we can get nth order polynomial only. So based on the number of data points, suppose if we are having only 5 data points, then you can get fourth order equation, a maximum of fourth order. Okay, so like this, we can develop the relationship between the y and x, and we can fit the curve within the measured data points. So this is curve fitting. So in interpolation techniques, if we have a set of data points, measured data points, if we want to measure the value at any unmeasured value, then we can measure that, or we can estimate the second set of data points from the first set of data points. Okay, using the interpolation technique. If we are having a measured data points at set given values, then at that any desired value, or here, or here, or here, at any desired value, we can estimate the second set value. And in curve fitting, we can develop the relationship between two data sets that we have obtained from the practical experimental data. This is interpolation curve fitting. Any queries you can ask.
Okay, thank you, sir.
Thank you, sir.
Thanks for your lecture. And request all the participants, if you're having any doubts, you can please ask